There is a place in the universe where the magnetic field is 1,000 trillion times stronger than Earth's. If you floated even 600 miles away from it, the sheer magnetic force would instantly dissolve the atomic bonds of your body, turning you into a mist of subatomic particles. Welcome to the most dangerous place in the cosmos. For decades, scientists thought supermassive black holes were the ultimate cosmic killers. But this object defies everything we know about physics. A single teaspoon of its material weighs 1 billion tons. It spins at 20% the speed of light. And in a fraction of a second, it can release more energy than our sun will produce in 100,000 years. By the end of this video, you'll understand why astrophysicists are deeply divided on how these impossible objects even form, and why they are terrified of finding one too close to home. To understand this anomaly, we need to look at what happens when a massive star dies. Normally, when a star runs out of fuel, it collapses under its own gravity, exploding in a supernova and leaving behind a hyperdense, spinning core called a neutron star. That's established, predictable astrophysics. But this is where things get strange. Because a tiny fraction of these dead stars refuse to follow the rules. They twist their own magnetic fields into a tight, volatile knot. The expectation was that they'd eventually cool off and go dark. The reality? They become ticking time bombs. What I'm about to reveal next is why so many people are joining us here at Deep Space Secrets every single day. If you want to uncover the universe's most heavily guarded mysteries alongside a community of curious minds, hit that follow button right now. Because the true story of how we found this cosmic monster is going to give you chills. The date was December 27, 2004. NASA's Swift Observatory and the windswept radio telescopes of the Very Large Array suddenly maxed out their sensors. A blinding flash of gamma radiation had just slammed into Earth's upper atmosphere. Dr. Brian Gensler and his international team scrambled to trace the signal. Initially, they assumed it came from our own galactic neighborhood. But when they pinpointed the exact source to a location 50,000 light-years away, a chilling realization set in. For the radiation to be that strong from that incredibly far away, the explosion had to be astronomically violent. What on earth had just detonated? The culprit wasn't a supernova or a black hole collision. It was a starquake on a magnetar named SGR 1806-20. Imagine an earthquake, but instead of shifting tectonic plates, the hyperdense, solid iron crust of the stars snaps under the tension of a 1 trillion Tesla magnetic field. Dr. Gensler noted that if this exact event had happened just 10 light-years away, it would have entirely stripped Earth of its ozone layer, triggering an immediate mass extinction. It perfectly explained the data, but it left scientists with a terrifying new cliffhanger. If magnetars can randomly detonate like this, how many are hiding right in our cosmic backyard? But here's where it gets crazy. Just when you thought you understood the threat, new data from the James Webb Space Telescope flipped the script. We used to think magnetars only formed from the death of supermassive stars. But recently, researchers found one in a cluster of stars that were mathematically far too small to create one. This sparked a massive debate. Are they formed by two smaller stars violently merging? Or is there an entirely unknown, invisible mechanism compressing these stars into magnetic monsters? The truth is, we might be completely wrong about where they come from. I genuinely want to know what you think about this. Are magnetars the result of binary star collisions, silently merging in the dark? Or is there a completely unclassified phase of stellar evolution we haven't discovered yet, a missing link in astrophysics? Drop your wildest theories in the comments below. Scientists around the world are actively debating this right now, and sometimes the best outside-the-box thinking comes from communities exactly like ours. Which theory do you side with? Let me know. Stay with me here, because this affects how we see our place in the universe. If magnetars can form from smaller, everyday stars, it means our Milky Way galaxy is essentially a cosmic minefield, filled with thousands of these volatile objects lurking completely undetected. This isn't just about staring at pretty, distant lights, this is about planetary defense. Mapping the exact locations of these dead stars is crucial for the long-term survival of humanity. If we ever want to become a multi-planetary species or send generation ships out into the deep dark, we have to know exactly where the universe's ultimate kill zones are, so we can avoid them at all costs. But thankfully, we aren't flying blind anymore. By the end of this decade, humanity's tools for mapping the dark will take a massive, unprecedented leap forward. The upcoming Nancy Grace Roman Space Telescope, launching in 2027, combined with next-generation gravitational wave detectors, will allow us to see the invisible fingerprints of these magnetic giants long before they erupt. We are entering a golden age of astronomy where the universe can no longer hide its most dangerous secrets. Every single time we look up, we aren't just finding new threats, we are actively mapping our safe passage through the stars. But this isn't the only cosmic terror lurking in the dark. What you're about to see in our upcoming videos changes everything. Next week, we're investigating the Great Attractor, the invisible anomaly that is dragging our entire galaxy toward it at 1.3 million miles per hour. And after that, we're decoding a classified anomaly found buried in the ice of Antarctica that shouldn't exist. You won't want to miss either of them. Thank you for exploring the unknown with us today. Remember, the fact that we can look into the most dangerous places in the cosmos and live to tell the tale is proof of just how far humanity has come. The universe is full of secrets, and we're just getting started. Stay curious, keep looking up.